Hey, hi everyone. Welcome back to my YouTube channel. My name is Savita and I'm back with another exciting and important video. So guys, in this particular video, we're going to discuss about the knowledge distillation. So this knowledge distillation is a part of this fine tuning playlist. In this particular video, I'll tell you the core concept of the knowledge distillation and how it could be useful in terms of fine tuning. So both things we're going to discuss in terms of theory as well as practical. If you don't know guys, I started one fine tuning playlist. In that so far I have uploaded 9 videos. So where you can find out all those videos, if you will go and check with the playlist section, there I already created one playlist, complete LLM fine tuning. You will get all the fine tuning videos over there. Apart from that, you can check out with the videos section as well. So the last class, in the last video, I discussed about the fine tuning of the Bert model. Bert is one of the classical model. In this video, I explain about the Bert fine tuning as well as I given you the overview with respect to the other models as well. Now before that guys, I discuss about the Hugging Face. Hugging Face is a very important framework. If you're gonna learn NLP, generative AI, you will find out so many models, so many data set, and even the different services over the Hugging Face, which you can directly utilize freely guys. Okay, now guys, inside this particular playlist, as you can see, there is a 9 video and there I covered all the fundamental concept related to the fine tuning. Now after this particular video, after the distillation, one more video will come with respect to the quantization, because quantization is also one of the important concept in the world of LLM fine tuning. And then we'll start with the implementation, different framework, different data set, different model, and we'll try to fine tune each and every model over here with the different techniques. Okay, so now guys, first of all, let me show you that what all thing we are going to be cover up here. So this is the points guys, points to be covered. So first we'll try to discuss about the knowledge distillation, that what is the knowledge distillation in the deep learning. Let me zoom in a little bit more so that you can see clearly. So here guys, you can see so I capped the point about the knowledge distillation. Then we'll discuss about the concept of the teacher and the student model, that what is a teacher model, what is a student model. Then we'll discuss distillation in the neural network. So on a fundamental level, I'll explain you what is the knowledge distillation in the neural network. Then we'll see distillation in the large language model. We'll discuss in terms of the large language model as well. We'll see the theory as well as the code implementation. Both things we are going to be cover up in this particular video. Now apart from this one, you will see the normal fine tuning versus distillation. We'll see the differences between the fine tuning and the distillation, and when we have to use which concept. Then guys, we'll come to the next point, where this where to use this distill model. Now what is the utilization of it, what is the advantage of it, right? So each and everything we're going to discuss inside this particular section. Then guys, we'll come to the overview of the DeepSeek distill model. You know guys, DeepSeek have been trained on top of the distilled knowledge, right? So it has distilled the knowledge from the GPT model itself, and many like in many blogs, in many and even in the official research paper of the DeepSeek, that thing have been confirmed. I'll show you those resources as well as the DeepSeek model. So I'll give you the overview of the DeepSeek model, so your understanding of the distillation with respect to the large language model will bit more clear. Okay, so these are the point guys. I hope it is clear. So step by step, one by one, we're going to discuss each and every point. Now apart from this one, let me show you the code base also, the code base which I created for all of you. Here guys, this is the complete code base. Inside this file I capped the entire code. So we're gonna discuss the code from very scratch. I'll tell you each and every fundamental concept. Then right after this deep learning concept, I'll come to the LLM. So that LLM code also I capped over here. We are going to be read the different LLM. So LLaMA we are going to be read, and even I'll show you with the classical model like Bert and all. Okay, so each and every technique we're gonna see in terms of the practical. So stay tuned in this video. and you will learn this knowledge distillation, and you will learn like how does it work and the differences with the normal fine tuning. So guys, if you haven't subscribed my YouTube channel so far, please go and subscribe, because you will find out these type of video in the near future. And yes, I will be coming up with more exciting content. Now let's do one thing, guys. Let's start with the knowledge distillation. So first, we'll start with the definition of the knowledge distillation. So I created the entire notes for all of you guys. See, this is the complete notes. Okay, and we'll see with some diagram also. I'll explain you this particular concept using some diagram, and I kept some real-time example also. So let's discuss the definition at the first place, that what is a knowledge distillation. So a knowledge distillation is a technique used in deep learning to transfer the knowledge of the large heavy model, this is also called the teacher model, okay, into the smaller or lightweight model, which is called the student model. Okay, so in the knowledge distillation we have a concept of the teacher as well as the student model. Now guys, you can see the analogy. I'll explain you this analogy. By studying the teacher notes, the student can pass the exam with less effort instead of studying everything from scratch. So we'll have to understand this particular analogy at the first place. Okay, then only we'll be able to understand the concept of the knowledge distillation in a better way. Now, before coming to this analogy, or before coming to the core definition, the core concept, let me give you the idea that from where we got this distillation idea. Okay, this distillation thought. So Geoffrey Hinton, Oriol Vinyl, and Jeff Dean introduced this concept in 2015, right? So here you can see the research paper. I kept the link of the research paper over here. So once you will click on it, you will be directly redirecting to that specific research paper. So guys, inside this research paper, the complete concept of the knowledge distillation have been explained. So the date was 9th March 2015, when this Geoffrey Hinton and this guy, wait guys, let me open it again. When this Geoffrey Hinton, Orion Vinyl, and this Jeff Dean was working in the Google, at that time they have came up with this particular concept. So at this time guys, the deep learning was getting a little popularity, and community was working on so many CNN based model. Okay, so inside this research paper guys, the complete formula as well as the complete benchmarking with respect to this knowledge distillation and all, everything have been explained. If you want to be deep dive into that particular concept, then for sure you can refer this research paper. Now I will try to simplify this entire research paper, this entire process in my explanation, and I'll give you the complete end-to-end explanation with some diagram. Okay, so I'll give you this research paper link. For sure you can look into it. So let's check out with the other point. So distilling the knowledge in the neural network. So this was a Google research work, and the paper demonstrated that a smaller model can be accurate as a large one when trained using the soft target. Okay, so guys, whenever we are talking about this distillation, so we need to understand some concepts. The concepts include teacher model, concepts include student model, soft loss, okay, soft target, hard target, okay, and we have to understand one loss function as well. So I'll show you the formula of that particular loss function, which is a combination of the cross entropy and KL divergence. Okay, so those are many things we need to understand. Now where it is being used, where this Distill model is being used, so here I kept a couple of points, and for sure we're going to discuss these particular point in the upcoming in this video itself. Okay, so now here is a teacher model, right? Now the concept of the student model. Then here you can see the loss function, right? So the loss function, basically it's a combination of the cross entropy loss and as well as the KL divergence loss. Then we have a hard level. Okay, we have to understand about the hard level, which is also called the ground truth. Soft level, which is a teacher prediction. It is a softmax prediction, right? You know about the softmax. So softmax is going to predict the probability. So it is a softmax prediction. And here is a loss function, guys. This is what? This is a loss function, which we're gonna use while we are going to be distillize the knowledge, right? So these all are the concept which I capped in terms of theoretical points over here. Step by step, one by one, we need to understand all this concept. Okay, so first let's start with this analogy. Like, what is this analogy? Okay, and what we are going to do inside the distillation, the knowledge distillation. So here guys, I capped one diagram. Let me show you that specific diagram. First of all, let me clear this entire screen. As of now, it is not required, so I'll write everything from scratch itself. So give me a moment, let me clean it up. So perfect guys, now I have let me copy and paste one diagram. So the diagram includes the entire analogy, the analogy which I was trying to explain. Okay, so inside this diagram you can see we have a teacher, right? So the lady, actually she's a teacher. Let me write over here, and here is a student. Okay, so here is a student. Now you can think this student is going for the exam, he's preparing for the exam. So how this student can prepare for the exam? This student can prepare by himself, means he can go through with the internet, he can go to the Wikipedia, chat GPT, or he can go through with the different books and all, right? And he can acquire the knowledge with respect to the specific exam, right? And after that guys, after acquiring a knowledge with respect to the specific subject, now the person is going for the exam. Okay, this is the one way. Now what is the another way? The another way is, so this person, right, this student can gather some notes from the teacher who already knows about this specific subject. Okay, this teacher is a subject matter expertise, so this teacher have prepared some notes. Now this person, now this student can directly consume this specific class notes, and he could be appear for this particular exam. So there is two things. The first thing, basically, a student can himself prepare for the exam from the variety of the resources, he can gather the information. And the second one, basically, he can take the class notes, right? He can take a class notes from the teacher, and then only he can prepare for the exam. So guys, whenever we're talking about the knowledge distillation, so this knowledge distillation is based on the same concept. What does it mean, guys? So the meaning is very simple. So we have one teacher. The teacher is nothing, it is this teacher is a heavy model, heavy or the large model. Okay, heavy model, or I can say this teacher is a large model. This student, who is a student, guys? This student is nothing, student is a small model. In the world of deep learning, we always train a model. In the world of AI, we always train a model. So this student is nothing, it's a small model, right? He's a small model, right? So guys, now what he's doing, this small model is taking a knowledge. Okay, this small model is taking a knowledge from the heavy model, right? So this small model is taking a knowledge from the heavy model, or in short I can say this small model is distillizing the knowledge. Okay, distillizing the knowledge from where? From the heavy model, and then it's going to be perform their own task. That's a simple concept of the knowledge distillation. Now let me show you one more diagram. With that, your understanding will be a bit more clear. So here guys, you can see, so I capped one more diagram. So inside that we have a large model or the huge model. So this large model, it's a GPT model, as you can see. So large model is a GPT model. I capped couple of models, GPT 4.1, GPT 4.0, GPT 4.5. These are quite huge model, as you know. If you are familiar with the OpenAI based model and all, then you must be aware about these particular model, right? So we are going to be distillize this particular knowledge, the knowledge from these large model, from the huge model. Okay, and we are training this small model. So we are distillizing the knowledge from the large model to the small model. Okay, a small model. So there is a complete process for distillizing the knowledge. Let me write over here, distillizing the knowledge from where? From the large model to the a small model. Okay, I'll show you that specific process. I hope you understood this analogy, and I hope you understood the concept of the distillation. So this large model itself is called the teacher model, and this a small model is called the student model. Okay, so that's why I kept this diagram at the first place, and then I came over here. Now coming to the next part. So guys, here first of all, we'll have to understand about the model training. If you're familiar with the model training, let me write over here. So guys, whenever we're talking about the model, right? Model in machine learning. So model in machine learning in ML, or if we're talking about the model in DL, deep learning, that is RNN, sorry, ANN, CNN, RNN, okay, even the transformer based model, which comes specifically in GenAI. So it's having two phases. Every AI model is having two phases. The first phase of the AI model is called the training. First we train the model. Then the second phase of the model is called the prediction. We perform the prediction after the training. Okay, so we have a model in ML, classical ML, DL, in GenAI also, right? And in every sort of a every sort of a domain, right? ML, DL, or GenAI, we first train the model and then we perform the prediction. So guys, let's try to understand the training process, how the training happens. Okay, then only we'll be able to understand that how it is going to be distill the knowledge from the teacher model to the student model. So here you can see I kept one diagram, and with this particular diagram your understanding will be a bit more clear. So let's try to understand the training process at the first place. So in the training, guys, see, let's try to understand about the training process. So the training, what is required? So we require a data. So you can see over here we have three type of data, three classes in the data itself. We have cats, we have dogs, and we have rabbit, right? So this is my database, and in my database we have three type of classes. Now what we are doing, guys, we are going to be train one artificial neural network. Okay, we are going to be train one artificial neural network. Means see, we have a specific type of neural network which is called the CNN, that is called convolution neural network, but we can directly flatten this images, okay, without processing using the CNN architecture, and we can pass it to the artificial neural network. So as of now, this is just an analogy, or this is just an overview, so you can think whether it's a artificial neural network or it's a specific CNN neural network, which is specifically we use for the image data. Okay, so any one model you can think over here. You just need to think that this is an AI model. So here we have a database. Inside this data we have three classes: a cat, a dog, and rabbit, and we have the artificial neural network, means one AI model which we are going to be trained. And here, guys, this particular model is called the teacher model. Why it is a teacher model? I'll tell you that, because this model is bigger compared to the next model, which I will show you. Okay, so guys, what we are going to be we are going to be train this particular model. Now what is the training process for train any artificial neural network? Okay, so here, guys, this is the diagram. With this particular diagram we'll try to understand the training process of the artificial neural network. So first what we do, guys, we perform the first we perform the forward propagation. Okay, then what we do, we perform the backward propagation. As you know, right, we perform the backward propagation. So forward propagation is one thing, and then we perform the backward propagation. Now in the forward propagation, what we do, we pass the input. So this is my input layer. Okay, we pass the input. So this input comes to the hidden layers. This is called the hidden layer first, hidden layer second. Okay, then it goes to the output layer. So this is my output layer. So this output layer, it could be binary output layer. Okay, in the binary output layer we would be having one neuron. Binary means two classes, and this could be the we can design this output layer for the multiple output also. Okay, so multiple output. So this layer could be a binary output layer, or this layer could be for the multiple output also. So in the binary output, we use the sigmoid function, and the multiple output, we use the softmax function, right? So guys, whenever we perform the forward propagation, we pass the data from the input layer. So this input layer is nothing. We are going to be convert our data into the array, right? So this is my array. Now this particular data we pass to the hidden layer. This is my hidden layer. Now in the hidden layer, we have two operations. The first operation inside the hidden layer, which is called, guys, which is called the summation. So what we do, we perform the summation. Okay, summation. Now after performing the summation, what we do, we pass it from the activation function. Okay, we pass it from the activation function. So summation and activation function is this is the process which is happening inside the one single neuron. Okay, this is the operation which is happening inside the one single neuron. So after performing the summation, okay, of the entire input, and after passing it from the activation function, we pass it again from the hidden layer. Okay, then in the hidden layer, in the second hidden layer, in every neuron, the same thing is going to be happen, and then finally it comes to the output layer. Okay, in output layer also, what we have, guys, we have a activation function. Okay, if it is a binary output, then we have a this one sigmoid activation function, and if we have multiple output, in that case we have a softmax output function. Okay, softmax output function. Now guys, so we'll get an output. Now after getting an output, what will happen, you know? So after getting an output, guys, we'll try to compare this output. Let's say this output is called the bypredict. Now we are going to be compare this output with the original level. So this process is called the loss. We are going to be calculate a loss. Okay, so the entire distillation process is working around this loss only, right? This entire distillation process is working around the loss only. See guys, this is the artificial neural network. Okay, now we are talking about the CNN, convolution neural network. So in the convolution neural network, we will be having one more layer before this ANN. That particular layer is called the convolution layer. Okay, that particular layer called the convolution layer, that is just for the image processing. So we are just going to be find out a specific feature. We are just going to be extract the specific feature from the images, and then we are passing to the ANN. That's it, guys. Okay, we have one more type of neural network, the specific neural network, which is called the recurrent neural network. So we'll see in some other classes and all. We'll deep dive into those. If you want to be understand, if you want to be take a overview of all this neural network and all, you can visit my previous session also. There I given you the glimpse of it. So here, guys, what we do, we find out a loss. So we calculate a loss, guys. So we have a loss function, and after that, after calculating a loss, what we do, we back propagate. So we have a forward propagation. Okay, and then what we do, we do the backward propagation. So inside the backward propagation, we use the optimizer. Okay, so in the backward propagation, guys, we use the optimizer. I hope, guys, you are familiar with the different optimizer concept. Again, this is the part of the deep learning itself, means it comes inside the core deep learning, inside the artificial neural network. So we'll see the optimizer and all these particular concept in the upcoming sessions. Okay, so this is the complete process, the training process, right? So we have an input, then we pass it to the neuron. In the neuron, we have a summation, then activation function, then it is being passed from the different neuron, means different hidden layer. Okay, inside the hidden layer, we have several neurons, and then finally it is being passed to the output layer. In the output layer, we are going to be compare from the actual level, and here we are going to be calculate a loss. Then for minimizing this loss, we have an optimizer. So where we are going to be implement the optimizer, we are back propagating. Okay, we are back propagating, right? So what is a formula? Like when we back propagate, so one basic formula when we find out the gradient descent, let me show you both formula, loss function as well as the gradient descent formula as well. Okay, with that your understanding will be a bit more clear. So here, guys, you can see this is the formula for the cross entropy, this one. So here inside this particular formula, you can see we have this pi and log qi. So pi means what? It's a true probability distribution. And what is a qi? Qi means predicted probability distribution. Okay, so pi means basically true probability distribution, that is called a ground truth. Okay, the actual level. And qi means what? Which is a predicted one, which is being predicted from the softmax. Okay, this is the one formula for the cross entropy for the multiple classes. Okay, now let me show you the formula for the gradient descent. So here, guys, you can see this is the formula for the gradient descent. Okay, Let me keep it over here so that you can clearly see this one. So we have a so what we are doing over here inside the gradient descent for updating a weight, this is one of the optimizer, guys. So we are going to be calculate a new weight while we are going to back propagate. Okay, so it's a old weight, we are going to be minus from the from this particular value. So this is called the learning rate. Okay, and we are what we are doing here, we are going to perform the derivative of the loss function. So this loss, it could be a cross entropy, it could be binary cross entropy. Okay, it could be any basically other loss. So RMSE, right, root mean square, or the other different loss for the regression and all. MSE could be there. Okay, RMSE, MSE, this loss could be there. Cross entropy, binary cross entropy, RMSE, MSE, ME is also one of the loss for the regression. Okay, so this is one of the optimizer. Using this optimizer, what we do, we train the neural network. Okay, we train our network. So now we have very advanced optimizer, ADAM optimizer. Okay, we have basically different variants of the ADAM optimizer, right? Generally we use that ADAM optimizer only while we train the neural network or any other model like transformer based model and all. Okay, so there is a complete history behind this optimizer. We can understand this entire neural network concept and all in some upcoming classes. So this is a complete process, guys, process for the training. So you can think in such a way that we have a database, we are going to be trained one neural network. Okay, so this is the complete process of the training, and here this particular model is called the teacher model. Okay, now let's understand the next part. So here, guys, I kept one more image. With that maybe your understanding will be a bit more clear with respect to this particular training process. So let's say if we have an image, right? So here what we have an image. So this image we are passing, where? Into the neural network for the training. So this is the image, and how we will pass the label? We'll pass the label like this. So how many classes we have? We have 3 classes. The first class is cat, the second class is dog, and the third class is a rabbit. Okay, rabbit. So guys, how I will prepare the label for this particular image? So I will keep cat as a 1, dog 0, and rabbit 0, and here is my cat image. Okay, cat image. Now there could be a dog image. If we have a dog image, then how I will prepare a label for the dog image? So here would be 0, there would be 1, and there would be 0. Okay, now let's say I have a rabbit, the other class, the third class. So how the third image basically, so how I will prepare a label for that? 0, 0, 1. So this is the label for the rabbit. So cat, dog, rabbit, I'll be passing the data from the neural network. Okay, then it's going to be predict this 3 output. Now this is called my predicted value, predicted probability, right? So this is my this value coming from where? This value is coming from the softmax. If you know about the softmax, then I think you can understand how this probability is being calculated. But as of now, just understand on a functional level, not on the not on that mathematical level. Okay, so we have an image, we are passing the label. Okay, we are passing it from the neural network. It's going to be predict. See, this is a training process. Okay, one more thing you have to be keeping in mind, that this is a training process. So we have an image, guys, we have a label, we are passing it from the neural network, and we are going to be predict the probability, right? So for the cat, this one, for the dog, this one, for the next class, here is a probability. Okay, so this is my predicted output. Now what I will do, I'll compare it from the actual output. So what is the actual output? 1, 0, 0. This is my actual output. Now what I will get over here, guys, I will find out the loss, right? And this loss basically we are going to be calculate using the cross entropy, right? So we have our loss function. The loss function is called the cross entropy, and we are going to be calculate a loss using this specific function. I hope you understood the entire training process. Now, why I was telling you this entire training process, I'll let you know, because for understanding this distillation process, you will have to take a look on this training process. Okay. Now, guys, let's do one thing. Let's try to understand the soft level and the hard level. Okay, and then I will show you the prediction part. So whenever we're talking about the soft level and the hard level, guys, so this probability, right? Here, let me write the hard level. I'm going to be right over here, hard level. Okay, so this hard level, this is nothing, it's a softmax probability. So the softmax probability basically, which we are going to be calculate, these are the probability 0.37, 0.50, 0.13, right? So this is what, this is the hard level, sorry, this is the soft level. Okay, let me remove remove this one. This is called the soft level. Okay, so here I can write soft level. And this is the softmax probability. Okay, soft probability means what? It is a softmax. Softmax is what? It is the activation function. Okay, if we're talking about the hard level, so this hard level is nothing. This hard level is this one hot encoded vector, which is 1001 or 010 or 001. So this is called the hard level. Okay, I hope you understood what is a soft level and what is a hard level. Now guys, after performing a training, right, now if I'm going to be perform the prediction, right, so let me take one more image, and here let me keep this particular image over here and try to understand the prediction pipeline. So let's say we have a trained model now, which we have trained on a 3 type of images. Now what we are going to be do, we are going to be perform the prediction on this trained model. Okay, so we are going to be perform the prediction on this trained model. We are passing an image, guys. So here is an image. As you can see, this is my image. We are going to be pass this image, and this image is going through the artificial neural network. Okay, then we are going to be predict the softmax value, right? So here is what? Here is my softmax value. Okay, so let me write over here the softmax value. Now the softmax value, the softmax probability itself is called the soft label. Okay, and then guys, we are getting this particular vector means 0.7, which is the highest one. Okay, so here the one will come 0 0. So for the cat only, we have assigned this vector while we were doing the training. So this was the label for the cat. So here it is doing a right prediction. I hope you are getting right. So this is the cat, guys. So during the training, this level was assigned to the cat 100. Now this cat image will go to this artificial neural network. It will predict the probability. This probability is going to be a softmax probability. Okay, and then will convert into the one hot encoded vector means 100. So this is the correct value, correct prediction. So this particular probability is called the soft label, and this particular values is called the hard level. I hope guys you understood the complete training. You understood about the teacher model, means my actual large model is called the teacher model, and you understood about the prediction as well. Okay, and during this entire thing, there's 3 important terms. First is the teacher model, second is the soft level, and the third one is the hard level. Now let's understand about the student model, guys. So guys, here you can see the student model. So student model is nothing, it's a small model. Okay, so this is the student model, and inside this particular model you can see we just have 2 hidden layer. In the previous teacher model we were having more than 2 hidden layer, which so see how many hidden layer was there? 3 hidden layer was there, 1 2 3, right? So what is the moral of the story here? The moral of the story is very, very simple. A student model is going to be a small model, and teacher model is going to be a larger model. So we have to transfer the knowledge from teacher to student. Okay, so just think over here, guys. We have one student model. Okay, now there could be 2 scenarios. So see, a student model. So again, if we have any model, there will be 2 phase of it. First phase of it is going to be a training, and the second phase of it is going to be a prediction, right? First we'll train the model, and then we'll predict the model, predict the basically whatever like input we are passing. Based on that, it will provide me a prediction. So training, guys, let's say we have a small model, small neural network, and we are going to be train it on one small data. Okay, or the data could be same, means here the data could be same, means the size of the data is same, or it could be less or more. Okay, that's fine, that's completely fine, but the size of the model is going to be different, means the size of the model is going to be lesser only. Okay, now guys, over here you understood the teacher model, which is a bigger model, a student model, which is a smaller model, which have been trained on the same amount of data or more or less data. Okay, now what is a distillation over here? What is the meaning of the distillation? So here I mentioned one line. The line is knowledge distillation from teacher to student. It is a special fine tuning, okay, or retraining the student model using a special loss function. I hope you understood it. If you haven't understood, let me explain you that, and then I will come to the practical. So let's say we have a teacher model, guys. Here I'm going to be write teacher model. Okay, now this is the large model. Okay, now here what we have a student model. Student model. Now this student model is a small model. Okay. Now we have to teach this student model, okay, using the knowledge of the teacher model. So we have to transfer the knowledge from the teacher to student. So how we will teach to the student model? So we'll be having one special loss function. Okay, you understood the training process, what happened in the training process. First, we pass the input. That input goes through the network. Then we calculate the loss. Okay, and then after that we backpropagate, we update the bit. Okay, and this thing is going to be in a loop. Means again we'll pass the input, then we pass it through the network, then again we calculate the loss, then again backpropagation, until and unless we are not going to be reduce this loss. Okay, our main aim to reduce the loss or optimize this loss. So we are going to be use a specific loss function over here. Now guys, whenever we talking about this student model, so here let me write this student model. So this student model, there could be two types of this student model. First, we just initialized, okay, with some random weight. Okay, means we haven't performed any sort of a training. With respect to this student model. Means we just initialize the model. Okay, let's say we have an artificial neural network. In that artificial neural network, we have one input layer, we have one hidden layer, and we have one output layer. Okay, so this is my artificial neural network. So we just initialize this network with the random weight. Okay, random weight. We haven't trained it still, right? So this is the first type of model. First type of student model. Let me write over here. This is the first type of student model. The second type of student model means, let me write over here, or let me take a different color so that you can understand it clearly. So the second type of student model, the model basically which we have trained. Okay, second type of student model. The model, let's say we have the same model, this one. Okay, now the model which we have trained on some data, this one. So we are passing some data to this model and we have trained it. Okay, so guys, this model we just initialize, we haven't trained, and this is the second type of model, okay, which we have trained. Getting my point? So guys, over here we can perform the knowledge distillation. Means we have a teacher. Let me take a teacher, guys. So here we have a teacher. Now this teacher can pass the knowledge, means we can retrain the model, this ANN model, the first type of model which we have initialized with a random weight. Okay, now let's say we have a teacher model. Okay, we can retrain the second type of model also, okay, which we have already trained on some data. So the moral of the story is very, very simple. We have a teacher model. We can transfer the knowledge to the model, okay, which we have just initialized. We have not trained yet, and we can transfer the knowledge from the teacher model to the ANN model or to the AI model, which we have already trained. Okay, so guys, over here the line which I have written, now you will be able to understand clearly. Knowledge distillation from teacher to student, it is a special fine tuning. Okay, special fine tuning means it's a special fine tuning where we are going to be retrain the model which we have just initialized, or we are going to be retrain the student model which we have already trained with the special loss function. I hope you understood it. Okay, Now once I will show you the practical, in that case the understanding will be bit more clear. So let me open the practical, guys, and then I will start with the code execution. So guys, step by step I kept all the points inside the ipynb file also. So as you can see over here, this is a step-by-step explanation of the entire this entire implementation. So at the first place, let's try to understand the code. So we are going to be import couple of module. First is a torch, then from the torch there is a neural network, then optim is there, then data set and transformer, and then data loader. Okay, so let me execute it. And here guys, what I'm doing, I'm going to be like run this transformer.compose. So it will convert the normal tensor into the PyTorch tensor, and then it's going to be normalize the data. Okay, so we are going to be normalize the data using this particular formula, this one. Now why we perform the normalize? So that my value could be centered around the 0. Okay, centered around the mean, which is 0. Okay, and we can do the faster training, and we can reduce the risk of the vanishing and the exploding gradient. Now here what I'm doing, I'm going to be perform the pre-processing. So I just create the object, and then I will pass this particular object over here, right? So this is my data, guys: train data, test data, train loader, and test loader. So first we have loaded the data, okay, and then we have converted into the Hugging Face specified format, right? Now after this one, guys, what we'll do, we are going to be visualize this data. So for that we are going to be use the matplot library over here, and then here is my images. So in total I'm going to be visualize the 8 images. Okay, so 1 to 8. Now if I'm going to be executed, so see, along with the label you will be able to see the images. So this is the MNIST data set, which is having the handwritten images. Okay, now what I'm doing, guys, I'm going to be train my teacher model, teacher multi-layer perceptron. So this is the class for that. Okay, and over here you can see we have an input layer. This is my input layer. Okay, this one. Now we are going to be connected with the hidden layer. So here is my hidden layer. Then this first hidden layer is going to be connected with the hidden layer 2, and then finally we are going to be connected to the output layer. So we have a 10 classes, 0 to 9. 0 to 9 means 10. Okay, it's going to be predict 10 number. So this is for the forward pass, guys. Okay, so this is the class which we are going to be create for what? For performing the training of the teacher model. So here I'm going to be pass the hidden layer 1 size, hidden layer 2nd size, and here is my teacher model. Now you can see the teacher model. So this is just the initialization of the model, the term basically which I was explaining you just right before this practical implementation itself, that we are going to be initialize a model without training. So here we have just initialize the model with the random weights. Okay, so now guys, what I'm going to be do, I'm going to be perform the training of this teacher model. So we have a model over here. We are going to be pass a data loader. Now here is a number of epochs. So as of now I'm just going to be keep single epoch so that I can make process faster. Then we have a learning rate. Okay, while we are going to be train the model, at that time we are going to be use this learning rate for the better conversion. Okay, so I'm going to be use this Adam optimizer, right? And here is my loss function, which is a cross entropy, because we have more than 2 classes. Then here I'm going to be initialize the training of the model, and then this is a complete training process. Means here I'm going to be calculate a gradient. Okay, then I will be getting a I'm going to be optimize. I'm going to be opt this gradient. Okay, means we are going to be calculate a gradient. Will perform the back propagation. Here I'm going to be calculate a loss. Then it will go backward. It will perform the back propagation, and then it's going to be calculate the updated weights and all. Okay, then here will be my total loss. So this is going to be complete training process. So let me execute it, guys, and here I'm going to be train my teacher model. So see, I got I will get my teacher model. Okay, after the training. There's going to be started training. It might take some time. Now if you want to be check the weights, the updated weights, so over here you can run this teacher.static. With that you will be able to find out the updated weight after the training. Whatever weights would be there, you will get over here. Now see, my training is completed. I was just having single epoch, so it has completed a training within a minute itself. And now if you want to check the updated weight after the training, you can simply execute this thing. Okay, so with respect to each and every hidden layer, you will get that. Now coming to the next part. So here what I'm doing, guys, so here see, there is a way like we can freeze this teacher weight. Okay, and then we can perform the training of the student model. So we have one more way without this freezing, without freezing explicitly like this. This is one of the way, but without freezing this one, without freezing explicitly. Okay, you can freeze it inside the loop itself. I'll show you that part. Now here is my student model. So this student model basically it is just having one hidden layer, as you can see. So it's my input layer, which is going to be connect to the hidden layer, and we have a one hidden layer with a 128 neurons. So in the previous model we have two hidden layer with 512 neuron and 256 neuron. Okay, so I'm going to be create this student MLP multi-layer perceptron. So see, we have initialized the student model. Now as I told you, we have two approaches. The first approach basically without see, we have just initialized the weight of the student model. Okay, now what we can do, we can take this student model and we can train on top of the we can train the model on top of the soft label on the of the teacher model. Okay, and the hard level. So the soft level will take from the teacher model. Okay, and we would be having the hard level. Hard level means that one hot encoded vector. The soft like levels will take from where, from the teacher model which we have trained just now. Okay, so we can train this model, this random initialized model without, or we haven't performed the training on any sort of a data set. We can directly take this student model and we can train it. Okay, so let me show you that particular process, and then I will show you the second process, second approach, where we are going to be train the student model at the first place, and then we are going to be perform the knowledge distillation. Okay, so here is what, guys, here is my print model, the student model. So as of now, I'm not going to be train this student model. Okay, directly I'm going to be perform the distillation. So here is my distill training. Okay, so this is all the parameter for that. So first we have a temperature, then we have this alpha value. Okay, temperature and alpha, what it is, I will come to that once I will explain the formula I kept in my one notes. Okay, one note nodes, I'll show you that. Then we have a cross entropy loss, then we have a KL divergence loss. Okay, I'll come to that, and here my optimizer. So let me execute it, guys, and see I'm able to execute this particular parameter. Now this is a process for the distillation. So the distillation process, what we are doing, we are going to be pass the student, we are passing a teacher model, we are passing a data. Okay, on which data we want to be train this student model. So see, guys, this student model actually it's a without train model. Okay, the train model which we have just initialized with the random weights. Okay, then we have a epoch. So how many epochs we want to be executed? Let's say for the one epoch, one single epoch I want to be executed. Okay, then here what we are doing, we are going to be initialize the training of the student model. Okay, this is not going to be start the training, this is just going to be initialize the training. Now here is my total loss, which I'm going to be keep 0 as of now. Then here I have a loader, I'll take a x and y from here. Okay, and now here I'm going to be call this torch.noGrade. No grade means for this teacher model we are not going to be perform the training. So for that, what I have written torch.noGrade, no gradient. I'm not going to be perform any sort of a back propagation. I'm going to be use the pre-trained teacher model, and from here I'm going to be fetch the probabilities. Okay, the soft labels. Then here is my student output. Okay, it means I have a student model. To this student level I'm passing this data x. Okay, and then what I'm doing, I'm going to be use this torch.log softmax. Okay, so here I will be getting the softmax value from where, from the student. So see, here is a softmax value from where, from the teacher without training. Now here, guys, we have a student model. Now this student model I will be training, and here is my softmax value. Okay, now what I will do, I will calculate a loss. Loss means, so we have a KL loss. Here is my probability. Okay, this is my basically student probability. Here is my teacher probability. Here is my temperature. Then we have a hard loss. This is my cross entropy. Okay, means here I'm passing my logits, the probability basically for the student probability, and this is my labels. So this both loss we are going to be combined, and this will become my distillized loss. Now here is my optimizer. Okay, then this is my back propagation, guys. Okay, and here is my means I will perform the complete back propagation and all. Okay, for as many as epoch which the number which I have given. Then I will be calculating a total loss. Okay, and likewise I will be able to train my student model based on the teacher knowledge. So what is the teacher knowledge over here? What teacher is providing to us? Teacher is providing this this probabilities, this soft label. Okay, so on top of this data it is going to be provide this soft label without any sort of a training, guys. I'm going to be, see, it is kind of a prediction. So while I'm doing a prediction, I'm not going to be get a hard level, I'm not going to be fetch the hard level, I'm going to be fetch the probabilities. Okay, so this is my probabilities which I'm going to be fetch from the teacher model. Now here is my student model. Okay, on top of it I'm going to be perform the training. Now for the teacher model, I'm not going to be perform the training. I already written torch.no grades. Okay, now here is what optimizer.0 grade and all the complete loop. So this loop basically will perform the training of the student model. So let me execute it, and here once I will call this Distill, you will be able to train your model. Okay, that is student model. So see, the training of the student model has started. It will take some time, maybe 1 minute, and within that it will be able to train. So as you can see guys, my model have been trained, my student model have been trained. Now I want to be evaluated. Let's see the differences between the teacher accuracy and the basically this student accuracy. Okay, so here is my model. I'll be passing my model, I'll be passing my data, test data. Okay, and here the by default name is a model. So guys, what we'll do, we'll take a model. Okay, model.eval will initialize the evaluation. Now here is my correct and total, this two variable I have defined. Okay, just to test my model. So correct is there, total is there. Now see, with torch.no grade means we are not going to be perform any sort of a training, we are just going to be find out the output. Okay, so means we are just going to be perform the prediction. So here is my loader, I'll get my data. X means my label, the actual data, the images. Y means the label of it. Then I will be passing to the model, I'll be finding out the output. Here is my prediction. Okay, we'll get a prediction. So here guys, this is my correct value. Okay, so prediction would be there, correct will be there, and then we are going to be find out the accuracy, right? So likewise we are going to be evaluate our model. So here is I evaluate. Now here I am passing my teacher model. So see, with respect to the teacher model, how much is the accuracy? It's around 95%. Let's see with respect to the student model, what will be the accuracy. If I'm going to be checked, so here you will be able to see near to the teacher model. Now guys, over here we are going to be tested on the same data. Okay, we are going to be tested on the same data, and see, the teacher is generating 95% of accuracy and the student is generating 93% accuracy. Now if you will find out the differences between the teacher, okay, now see the teacher guys. So where is the teacher? So here is a teacher guys. So in the teacher, how many layers we have? In the teacher we have 2 layers with a huge number of neurons. But if you will look into the student model, so we just have one hidden layer. Okay, so let me show you the student model. See, we just have one hidden layer, and guys, the accuracy is near to the teacher model, because we are going to be distillize the knowledge. We are going to be use the soft probabilities from the teacher model, and on top of it we are going to be train it. I think guys, you didn't understand the entire concept. So let's do one thing. Let me give you one more example, and with that example let's understand this entire concept. Okay, and here is a further prediction on the like single data. So a single data point. So here is my predict. I will pass my test loader on it. Okay, one data point only. Then here is my student model sample batch. Now see the prediction. Okay, so this is the prediction which we are getting. Okay, now here see 72104 what this is, what guys, this is a label, the hard levels. Okay, now what we are going to be do, so here is my okay, it's a prediction basically up to 20 images. So for first image 7, for second image 2. Okay, it is saying it is the image on image 2 have been written, for the third image 1. Okay, similar to that, here you can see the true level. So the true level is almost same. Okay, so this is the basically predicted level using the student model, and here is a true level. Okay, now we can save this model as well. So we are going to be save this student model, and using this particular code we can save the model, and you will be able to get it over here, right? So I got my student model. Let me refresh it, and you will be getting it over here itself. So student model has saved with this particular name, and here it would be visible. As of now it is not coming. I don't know why, there is a network issue or something. Yeah, now I got the model. This is still student.path, right? So I hope guys this thing is pretty much clear to all of you, but maybe this process is not bit more clear, not that much clear. So let's take one more example so that it will be bit more clear. So first of all guys, let me show you one more thing. So here let me initialize this model one more time, because I'm going to be train my model, this teacher, this student model, and then I will perform the distillation. Okay, that particular part let me show you again. So we had a data guys, and here what we have done, we have initialized this teacher model. So let me initialize this teacher model one more time. Okay, now here is my teacher model, which we have initialized with a random weight. Now we are going to be train it. So yes, the training will happen over here, and see the training training has started. Now you can see the updated weight after the training. Okay, now if I want to be freeze the weight, I can freeze over here itself, otherwise I can freeze inside the Distill loop. Both is fine. Now here is my student model. So now this time what I'm doing, guys, so I'm not going to be initialized with the random weight. Instead of that, I'm going to be perform the training on top of some data. So here is my student model, guys. You can see the loader, the data will come over here. Here's my epoch. Only for one epoch I'm going to be trained. So this is the complete training loop. Okay, so I'm going to be executed this pre-trained student. Now after this one, I'm passing my student model and this train data, and this for the epoch one. So as I told you, the model is going to be small, but data could be same, more or less, okay, or it could be same as well. Now here, guys, you can see I'm going to be train my student model. So I got my student model. I will get my student model after the training. Now on top of this trained model, I'm going to perform the distillation. Okay, means I'm going to be utilize the teacher knowledge, and I'm going to be distillate the teacher knowledge to the student. And now this time this model is not an initialized model, it is a trained model. Okay, so let me execute it, and here this is a distillized loop. Now this is a this is a like function call. Okay, I am passing my student model which is already trained. Here is my teacher model, which is a huge model, the trained huge model. Here is my train data, train loader. And now what I'm doing, guys, I'm going to be retrain this model. This data could be some other data as well. Okay, this data, this train loader, okay, this could be some other data, means the updated data, updated database. Okay, updated database means what, with some more data. Okay, you can utilize the huge database if you are going to be retrain it, right? As of now, I'm just training with the same data. So student model is there, then training teacher model is there, and then there's a data. Now this student model is a updated this is a trained model now. Okay, so here what we have done, we have distillized the knowledge, and this is a special kind of fine tuning which we have performed on top of the already trained model, right? So now let me evaluate it again. Let me check the accuracy of the teacher and the student model. So the teacher is giving me around 94% accuracy, and the evaluation is giving me around, let's see how much accuracy. So it is giving me again 94% accuracy, guys, because this model is the trained model already, right? I think you got it. So what we can do in a two-way. First, we can take the model with a random initialized weight without the training, and we can distilize the knowledge from the teacher to this one, the normal model. So teacher to this student model, or we can pre-train, we can take the pre-trained model, and then we can distilize the knowledge. See over here, whatever numbers I'm getting now, it is a contradictory number because I just going to be perform the training for the one single epoch, but in a real time it is not a true thing. We are going to be perform it for the many epochs. Okay, so this result might vary, but yeah, this differences is going to be reduced as my teacher is able to perform in a similar way, my student will also be able to perform. So fine, I hope so, guys, this thing is clear. Now let's do one thing. Let's try to look into one very good example. With that, your understanding will be a bit more clear with respect to this knowledge distillation. Okay, so I capped one real-time example for all of you only. This notes is for all of you so that you can understand everything in a better way. Okay, so this is a real-time example. Let's try to understand this particular example, guys. So in this example, guys, you can see how many labels we have. We have three classes in the data set. The first class in the data set is cat. The second class is dog. The third class is a rabbit. So let's say this is my true label. If I'm going to be pass an image, let's say it's a cat image. For the cat image, the label was the 100. Okay. Now what we got, now when we are going to be predicted from the model. So let's say here is my model. What we have, guys, we have a model. Okay, let me write over here model. So we have a model. Now using the model, we are going to perform the prediction. So while we are doing a prediction, guys, we'll get two things. We'll get a probability. So let's say this is my output 0.7, 0.2, 0.1. Okay, and the one hot encoded vector of it will be 100. So this is my soft level, and this is my hard level. Got it? Now guys, see, this is what this is from the teacher model. Teacher model. Okay. Now guys, what will happen whenever we're talking about the student? Okay. So let's say we pass the image to the student. This is the cat image. Okay. Now we are passing the cat. See, we're talking about with respect to the training, right? Training. So we are passing the cat image to the student model. Now here I have a model. Now this model is a student model. Student model. Okay. Now this student model is going to be predict something. Let's say 0.5, 0.3, 0.2. Okay. Now how I will train this particular model? So we're going to train this particular model with a special loss function. So this loss function, here you can see the loss function, this one. Inside this loss function, we have cross entropy, where we are going to be find out a loss with respect to this hard level, this one. The second one, we have a KL divergence loss. So there we are going to be find out a loss with respect to the soft level. So how the loss will be calculated? As you can see over here, this is the probability, right? Now I hope it is visible clearly. So here how the loss will be calculated. So this is a complete formula of the loss. Let me show you the complete formula of the loss, how the loss will be look like. Just a second, I capped one image for all of you only, guys. I'm just going to be copy and paste that specific image so that your understanding will be a bit more clear. Where is that image? I had capped it over here. Okay, this is the image, guys. This is a complete formula. Now inside this formula, you can see, okay, so we have a cross entropy. Cross entropy of what? Cross entropy of the probability and the hard level. Okay, here 1 minus alpha, then t and alpha, this is a hyperparameter. It is called temperature, and this alpha basically it is also one more hyperparameter, okay, for regularizing the value of this KL divergence. Now we have a soft level. Okay, this is from the student, this is from the teacher. So this loss function we use for what? For the student model. Student model. Now I hope you got the process that what is happening. So we have a student model. This is my student model. Now my student model is going to be predict this value. Using this value, we are going to be find out a loss. And what is my loss function, guys? This is my loss function. It is a combination of hard, this one, and this soft. In hard, guys, we'll take two value. Which value, guys? In hard, we'll compare two value. First is this one, 1, 0, 0, and this 0.5, 0.3. The second value is going to be 0.3 and then 0.2. Now in soft level, we are going to be compared two value. The value is going to be 0.5, 0.3, 0.2, and the other vector was what? Other vector was the 0.7, 0.2, 0.1, 0.7, 0.2, 0.1. Okay, so this is for the hard loss, for the cross entropy. Okay, where we have a hard level and the soft level, okay, from the student, and KL divergence loss on top of the soft level itself. So this is the soft level from the student, and this value is coming from the teacher. So this knowledge, this soft knowledge, this one, soft level, this is only called the distillized value, this knowledge distillation. Okay, using this value only, we are going to be perform the knowledge distillation. I hope that everything is clear now, everything is picture perfect, and I hope you are able to understand it in a very well manner. Now guys, what I will do, I'll show you the distillation with respect to the other model, also the LLM model. Okay, maybe in the next video I'll try to explain that particular concept. So yeah, fine guys, thank you, bye bye, take care. And we have a couple of more points, so for sure I'll try to discuss this thing in the next video, because it's going to be a very long one, and I don't want to keep it like for 2 hour or 3 hour. Okay, within an hour itself I have completed this topic. So please watch out it completely and then be ready for the next video. Okay, I'll share this entire note so that you can go through with it. Thank you, bye bye guys, take care. I'll see you in the next video. Thank you.